Factorizing of cubic polynomials. So in theory, what are we doing? Let's say, for instance, I've got this equation and I need to find the x values. Okay, so let's go back to grade 10. What did we do when we had a function like this? Let's make it a function. And this was a parabola because it's to the power of 2. Because if it's to the power of 2, it can potentially cut my x-axis or intercept my x-axis at 2 potential points. So to find those x values, we actually made y 0 because on the x-axis, y is 0. And then we just factored this function out, and we actually got x plus 1 and x plus 4. So we knew then that x plus 4 equals 0, or x plus 1 equals 0. So x was a negative 4 and x was a negative 1. So on this function, I knew with these results that I've got two x-intercepts, which is negative 4, negative 1. So we made y 0 and we found the value of x, and that gives us x-intercepts. Now this is a very important thing when we start off with calculus, is that when we ever give it a function, we need to find those x-intercepts, which is very, very important. Okay, so how do I factor this one? How do I start factorizing this? For a start, whenever you factor, your first term should be a term with the highest exponent, and usually it is. So we usually write these equation in descending orders of powers. So this is already in the right shape, but I can't factor it out as soon as there is a negative in front of my first term. So I need to divide my whole equation with a negative. So this will change all the signs. So that's very important. Try not to factor. Please don't factor with a negative in front of my x squared or x to the power of 3. Okay, so now I've got a simple equation. I still need to find x. So the way I used to do this, and there's a couple of ways. There's a synthetic way of doing it, but I just use inspection. So what I need to find is I need to find some sort of factor of 9, which if I sub it into this equation in a value of x, so if I sub x with some sort of value, my equation would be equal to 0. So I need to find a value of x so that if I put it into my equation, it will give me 0. So in this instance, I've tried a couple, but when I subbed 3 into x's value, I actually got to 0. Okay, so that makes x equal 3 a factor. Okay, so that makes that tells me that I've got one x-intercept on my original function, which is 3. Okay, because you actually got a factor. Now I need to write this in 3 brackets. This would be the plan, to find 3 x-intercepts, because I've got a polynomial function which potentially can intercept my x-axis at 3 points. Not necessarily, but potentially. Okay. I know for a fact that x equals 3 is in factor, so I'm just going to change the sign of it, because if I take this bracket and I change it to 0, equal to 0, I'll find 3. So you have to take that factor and just change the sign of it. But now I need to find the other brackets. Now I can't find the other brackets first off. I need to sort of create a bigger bracket first, and then take this bracket and then make your 3 brackets. So you'll find your 3 x-intercepts. So firstly, we've got a factor, so we're just going to find the remainder of it. So think of this, to get to x squared, x to the power of 3, I need to multiply this with something. So I need to multiply it with x squared, and that will give me the value of x3. And the other thing as well is I need to look at my last term, this negative 3. I need to multiply it with something So the result is -9, and that makes it just a +3. Okay, and then we're gonna put a bx in the middle. Now we need to find the value of that b. Now I've got two ways of doing it, and I'm just going to do it parallel to each other. Firstly, and you need to know both, because sometimes you don't have an x in your equation, and sometimes you don't have an x squared in your equation. So it's very important to know both ways. So we're just going to multiply these two terms. We're going to multiply these two terms, and that should give us an answer of -15x. Okay, so that's the first way. So let's do it. So we'll take x times 3, which will give us 3x, -3 times bx, -3bx, and that's equal to 15x. So we need to find the value of -3bx. So -3bx, we're just going to take the 3x across. So change its sign, so it becomes a -3x, so this is 12x. So to find b, we're just going to divide both ends with a -3x, so that will become a -4. So now what we know is, we know that my first bracket is x minus 3. We actually have found the b value, and that's equal to 0. But I want to do it in a different way as well. So take note of this. So it's the first term of my first bracket multiplied with the last term of my larger bracket, and then my second term of my first bracket multiplied with the middle factor of my bigger bracket, and that gives you the x value of my original function. Okay. Alternatively, we can do it slightly different, and you need to know both. I'm just going to show that this will give us exactly the same answer, but the way we can do it is we're going to multiply this with the second term, and this with the first term, and this should give us, let's do this in a different color. Sorry, let's just do this in a different color. Let's do this in green. So we're going to multiply this with, missed it over there, and we're going to multiply this with this, and this should give us this value over here. Let me just underline it, that value over there. So let's do it. So x times bx, so it's bx squared minus 3 times x squared is minus 3x squared equals to -7x squared. I'm going to take the -3 across to the other side, becomes a positive, so this is -4x squared, and we're going to divide both ends with an x squared, so we can find the value of b, and we actually found the same value. So in theory we can do it both ways, and you need to know both ways. So when I factored this out, I actually got to these two values. Okay, but now we're not finished. We still need to factor out this bigger bracket. So we're slowly getting there, but this becomes easier. And I think this is quite straightforward. It's an x and an x. This is a positive, so we know our signs is going to be exactly the same, so but they're both negatives. 3 and 1, I think, yeah. So we've in theory got x minus 3, x minus 3, x minus 1. So I've got 3x values, x equals 3, or x equals 3, or x equals 1. So you can see that these values are exactly the same. So in this instance, my polynomial function will only intercept my x at 2 spots, at 1 and at 3. So this is a negative function, so it goes downwards, and it's just gonna touch my function of my x-axis at that point, because these two values are exactly the same. So if they were different, it will actually intercept at more places. So that's how we find x or x-intercepts